All right, part 3. This is probably, people find this the trickiest part of this unit, but it's very step-by-step, and if you follow the steps, you get to the solution. There's not any critical thinking, really. It's really just make sure you follow the steps in order. So remembering the steps are going to be the most important thing. Okay, so this is how to balance redox equations. Now, these are tricky because we can't balance them like a normal chemical reaction where we just put coefficients out in front. And the reason is this number of electrons. The amount of electrons that the oxidation half is losing has to be the same as the amount of electrons the reduction side is gaining. But these electrons then cancel out of the overall final equation, so we don't see them in the chemical equation for the reaction. And so since they're kind of hiding in there, you have to find out what they are, make sure they're balanced, and then they'll disappear again. So it's like we have to uncover these hidden electrons in order to balance these equations. So we're going to use the half reaction method, and it's going to take, like, whether the solution is acidic or basic does change the steps on this a little bit. For this unit, we're going to focus just on the acidic solution, and then when we revisit redox reactions in the electrochemistry chapter, we'll go over this again, and we'll also learn the basic section. So we're going to just do acidic solution for today. It'll make our lives a little easier. Whoa, these are all the steps. So this is what you need to be able to do in order. So we already practiced this first one, separate into half reactions. What's nice is, for this, you actually don't even need to know which half reaction is which. You just need to be able to separate them into halves. Step 2. Oop, that's not what I want to do. Step 2, balance anything that's not H or O, which means normal balancing. So the way you balance things normal is with coefficients. Yay. Okay, now 3 is where things start getting weird, because sometimes you'll see a half reaction where oxygen kind of seems to come out of nowhere. And like, how do I balance it if there's not even any oxygens on the front side? Now, the way we balance it is that we realize we're in solution, which means that there's waters around. Okay, and the water's floating around. We don't write them in the reaction all the time because most of the time they're not participating like in precipitation reactions. They don't do anything, the waters themselves. But here they can, because that's what's going to be donating the oxygen. So I'll show you a full example in a second, but that's why what we're going to do is you're going to add H2Os opposite of any oxygen that is you need to balance. Okay, so instead of adding coefficients, we're going to add waters. Then when we add waters, we're adding extra H's that probably weren't there in the first place, so then we have to go back and balance those H's. So we're going to add H pluses to the other side, enough of them to balance out all the H's. At that point here, all of your elements should be balanced, but we're not quite done. Because then there's the electron piece. And remember, this is why this is so tricky, is that you have to deal with electrons. So you'll notice on each side that not only do we have to balance the elements, we now have to balance the charge. So for example, if I have a copper 2+ on one side and a copper that's just a solid, just not an ion on the other side, the elements are balanced, but the charges are not. So we're going to add electrons. And when we add electrons, we always add them to the more positive side. And we'll add 2 of these, because this is 2 negatives. And then they'll add to these 2 positives and make my 0 same as the other side is 0. So electrons always decrease the charge. So you always add them to the side that has a positive. So you add to higher side, to more positive side. Okay. From there, we need to make sure that whatever electrons are being lost in oxidation are the same as the number being gained in reduction. So we have to go and balance them. We'll do that by multiplying entire things by a coefficient. So when it says make E gain equal E loss, we're just going to multiply them by a whole number. So we're going to multiply until the same. And then when you add half reactions, you're just putting everything back together. Adding half reactions is put all the reactants on one side and then all the products on the other side, and that's called adding half reactions back together. And then 7 and 8 are just checking. So 7, you're going to cancel anything that's the same, and 8, you're going to check. So that's the steps. So let's see this worked out in an entire problem. Well, here's another version of how to do this, right? We separate the half reactions. We balance them except for H's and O's, but then we do O's and H's here, so we balance everything. Once they're fully balanced, we equalize the electrons. So like if this side oxidation is losing 2 electrons, and if this side reduction is gaining 3 electrons, that's not going to work out. So we'll have to multiply the entire oxidation half by 3 and the entire reduction half by 2. So that's this step to equalize those electrons. And then you add them all back together, and then you make sure anything that's equal is canceling. If you did this correctly, at this step you will always cancel out the electrons you added in. You should never end up with electrons in your final equation. Super. So here we have examples. The best way to see this working is to see examples. So my advice would be to also somewhere have open like a picture or written down those steps, because we're going to go through the steps together. We're only going to do the first one together here on this video. I have a separate video already made for the second one, so you guys can watch that if you want a second one. I'm just going to like fully put a new whiteboard in here. We're going to start from scratch. We have Mn plus 2 plus Bi O3 minus, making Bi 3 plus, and MnO4 minus. Okay, so step 1, split into half reactions. I don't really care which one's reduction, which was oxidation at this point, but I'm going to put everything with manganese together on one and everything with the, bismuth together on the other side. So I'm going to put Mn plus 2, making MnO4 minus, and I've got BiO3 minus, making Bi plus 3. Okay. All right, so these are my two halves. So we could do, let's just start with one half and then we'll go to the other. So let's start with this manganese. So first of all, let's do this. Each Mn, there's one here and one here, which means they're already balanced. So step 1, balancing the elements that aren't H and O, is already done. So what we're going to need to do now is balance out these 4 oxygens. So I'm going to add to the other side over here, well, I'm going to add, okay, if it wants to let me add 4 H2O. So now I have 1 Mn, 4 O's, and 4 O's. Super. But now I have over here, let's do another color, we have 8 hydrogens, 4 times 2. So I'm going to have to add 8 hydrogens to the other side. All right, at this stage, let's double check, all of our elements should be balanced. Mn, Mn, good. 4 O's, 8 H's, 8 H's. Super. All right, the next step is to do the charges. Charge is a little tricky. Waters have no charge, so this charge's only charge comes from this plus 2. And the other side has a minus 1, but each of these hydrogen ions has a positive 1, so I have 8 positives. So my overall charge on this side is actually positive 7. So we need to make sure we're always including any polyatomic ion charges, but also the H pluses. You almost always use them, and so just keep an eye out for those H's. Now the question is, which side now gets the electrons? You might think we put them over here to like add some things to make it equal 7, but actually we do the other way around. We have to take away the 7s. We're going to add on this side 5 electrons, because now that'll reduce that 7 down to 2. Remember, electrons are negative, and they will subtract from the charge. Okay, so now my charges are balanced, my elements are balanced, everything's balanced. I'm going to write these a little farther over because we're going to do the other side now. So now this half reaction is balanced, and I can tell now, since I'm releasing electrons as a product, this is my oxidation because I'm losing electrons. Plus, you notice the charges overall went up. But yeah, this is my oxidation. Now let's do the other side. Okay, bismuth is already balanced in itself. There's 1 and 1. So I'm going to add 3 waters to this side to make up for those 3 oxygens. I'm going to add 6 hydrogens to this side to make up for these 6 hydrogens. And now let's think charge. So this side I have a minus 1 and 6 hydrogens. And on the other side I have a plus 3. That's it. So this is plus 5 and that's plus 3. So remember, we add the electrons to the higher side in order to, reduce that down. So I'm going to need, on this side, if I have a 5 and a 3, I'm going to need 2 electrons to get down to plus 3 on each side. Okay. Now, both of our half reactions are balanced. So we can pause here for a second. At this stage, you should always have 1/2 reaction releasing electrons and 1/2 reaction gaining electrons. If both of your electrons are on the same side of the reaction, you've counted your charges wrong and you need to go back and rebalance. But you'll notice our next step is to make these electrons equal. Because if this left-hand one is making 5 electrons, I need to use up 5 electrons on that side. Now, there's not a super easy way to make 5 and 2 equal, but what I'm going to do is make them both equal to 10. So I'm going to multiply this side by 2 and multiply this side by 5. And now I'm going to squish them back together. We got to make sure we're multiplying the whole time. So what I'm going to do is take all the reactants from oxidation first and multiply them by 2. So I'm going to have 2 Mn plus 2 and 8 H2O. And now I'm going to take all the reactants from the other side but multiplying them by 5. So I'm going to have 5 BiO3 minus, and 5 times 6 is 30 hydrogens, and 5 times 2 is 10 electrons. Oh my goodness, those are all of my reactants. Okay, and now we write our products. So remember, I'm multiplying all these by 2, so don't forget this step. If it helps you out, you can put 2's, like multiply everything by 2 here before you put them together. If that helps you, I usually just kind of do it as I go, but sometimes you forget stuff, so it could be good to do this before you do anything else. Yeah, so you don't forget. But now let's do our products. So we'll have 2 MnO4 minus and 16 H plus and 10 E minus. And now the other side, 5 Bi plus 3 and 15 H2O. Goodness gracious, these get really long. All right, we put it back together. We are balanced, but we're not simplified at this point. So at this point, what you'll do is you'll go through it. Anything that's the same in the reactants and the products can get canceled out because they're not actually changing, right? And then we can do more than that because I have 8 waters and I have 15 waters. So I can't cancel all the waters, but I can cancel 8 of the waters. So these waters will go away, and this 15 comes down to 7. I can do the same for the hydrogens. I have 30 and 16, so I can cancel out 16, so that'll leave me with 14 hydrogens on this side. My last step is just to rewrite everything, but now a little bit more simplified. We have 2 Mn plus 2 plus 5 BiO3 minus plus 14 H plus, making 2 MnO4 minus plus 5 Bi plus 3 and 7 H2O. And that's my final answer. Now you'll notice that we could not have balanced this in the normal way because my initial reaction up here did not include any hydrogens or any waters, and those are necessary to balance this equation. The other thing you'll notice at the end is that if you did this correctly, all of the elements and charges should balance on both sides of the equation. So the elements you guys can figure out the same as normal balancing, but the charges are interesting. So we'd have, let me zoom out. Let's see if this works. Yeah, okay. There we go. So let's just check our charges on both sides just to double check that they're balanced. I have 2 plus 2 charges from that manganese. I have 5 minus charges from that BiO3, and I have 14 positive charges from that H+. So I have 4 minus 5 plus 14 equals 13. I did that math right? Yeah. Okay. Let's check our other side. I'll have 2 negative 1s from the MnO4 and 5 plus 3s from that Bi, and the waters are neutral, so I have negative 2 plus 15 equals 13. Oh, look at that. Beautiful. So your final product is lovely and lovely because it is fully balanced with both elements and charges, and these electrons that were there cancel out. What's interesting though, keep this in mind, whatever number that got canceled out here, 10 electrons, this is technically the number of electrons transferred for this reaction. So if they ever asked you how many electrons were transferred, it would be that number. We wouldn't use the 5 or the 2, we'd use the one that was similar and the same. That's going to come in handy for later calculations. But that's our example of how to do this. There's a second example right in your slides. So if you need another example, there it is. Feel free to watch that. And there's also a Khan Academy one that goes through the steps as well. So if you need more help and practice, they're there. But just follow the steps and you get to the final answer. Thanks for watching.